Good morning, everyone. So, in your the subject is hydraulic machines and industrial fluid power. In your hydraulic machines, first part is your hydraulic turbine. So, let's discuss about these hydraulic turbines. First of all, I am going to discuss these things in your hydraulic turbines. First part is your introduction. Second is your classifications of your turbines, then efficiencies, velocity diagram of turbines, and specific speed and performance curves of turbines. So let's move to the introduction part. First of all, what is hydraulic machines? Hydraulic machines are the device which converts hydraulic energy into mechanical energy or vice versa. That means it can convert hydraulic energy into mechanical energy or it can convert mechanical energy into hydraulic energy. So those are the hydraulic machines. These two things, energy, what is your energy? Hydraulic energy, it can be converted to mechanical energy or mechanical energy which can be converted to hydraulic energy. So in your hydraulic machines, there are main two types of machines. First of all, first one that is turbines. So in your turbines, what is happening? Hydraulic machines, these are the hydraulic machines which convert hydraulic energy into mechanical energy. So in your turbine, what is happening? Hydraulic energy is converted into mechanical energy. This hydraulic energy is both possessing what is that kinetic energy and potential energy. So what is the next part of your hydraulic machines? That is your pumps. Generally you have seen those pumps to lift the water, isn't it? So pumps are, what is happening in pumps? In pumps, mechanical energy is converted into hydraulic energy. So these are the two opposite, turbine and pumps. In turbine, your hydraulic energy is converted into mechanical energy, but in your pumps, mechanical energy is converted into hydraulic energy. So next year, in your turbine, there is a rotor inside a turbine. That rotor rotates due to the energy supplied by the hydraulic. So, main source of your energy in hydraulic turbine is your water. So, these are the general layouts of your hydraulic electric power plant. This is your dam. From the dam, water is flowing through pipes or channels to the turbines. So this is called your headrace and this is your penstock. Water is flowing from headrace to the turbine through penstock and the water is discharging to the tailrace. This part is called tailrace. This is your turbine. To the turbine, in turbine shaft, there is coupled with the generator and electric power is generated. This is the basic general layout of your hydroelectric power plant. So, in your power plant, first part is your dam. You know about dam, it is constructed across the river or channel to store water. This is nothing but a reserve. Next is your penstock, what I was telling. Penstock is the pipes or large diameter channels which carries water from the dam to the turbine. That is your penstock part. Next is turbine. Turbine, different type of turbines are there. We will see in that part. So in your turbine there is some pockets, vanes or blades over the rotor, and those vanes are striped by the water flowing from the dam to the penstock. So those pockets or vanes are rotating, and by that the shaft also rotates and we got the mechanical energy. Next is your tailrace. These are the four parts, main parts of your hydroelectric power plant. So this is your tailrace. Tailrace is your channel that is carrying water away from the turbine. Okay. Next part is your some heads are there. Cross head, net head. So what is your cross head? it is the vertical difference between headrest and tailrest. That is the vertical difference between headrest and tailrest. In your diagram, previous diagram, it is shown. See, this is your headrest and this is your tailrest. So difference is your gross head. Next is your net head. Net head is your effective head. What is the head available? What is actually available? That is your effective head. That is nothing but H equal to Hg. That means gross head minus HL. HL is your loss due to the friction. So HL is given by FL square by 2GD. F is your coefficient of friction, L is your length of the pipe, V is the velocity of water, and G is your acceleration due to gravity, and D is your diameter. Next, come to the next part, that is classification of the turbines. First of all, turbines are classified according to action of the water on the blades. Next is your direction of flow through the runner and specific speed of the turbine. Next, head of the water available and disposition of turbine shaft. So, in 5 ways you can differentiate the turbines. First one is your action of water on the blades. Second one is your direction of flow through the runner. Third one is your specific speed of the turbine. Fourth one is the head of the water available. And fifth one is the disposition of the turbine shaft. So let's come to the first part. That is your action of water on the blades. So according to action on the water on the blade, this can be divided into 2 types. First one is your impulse turbine. Second one is your reaction turbine. So next, come to what is impulse turbine. Next comes the impulse turbine. What is an impulse turbine? Impulse turbine is the turbine where pressure of the flowing over the rotor is constant. So what is happening in impulse turbine? Whatever the pressure available in the water, that is constant throughout the process. So potential energy or pressure energy is the main part that is functioning in the impulse turbine. Most common impulse turbine is your Pelton wheel turbine. Next is this is a diagram of your Pelton wheel turbine. See, this is your outer part, that is your casing. This is your shaft, that is horizontal. This is your water jet or water vane that is striking on the buckets or blades, which is fitted over the rotor of the turbine. This is a water jet. Spear is provided to control the flow of water. This is your deflector. This part is called your nozzle. So after exiting, the water is coming to the tailrest. This is your tailrest. So through the middle of the buckets or vanes, this is the pitch circle of runner buckets, and this is the brake nozzle. Brake nozzle means to control the speed or to stop the turbine. This brake nozzle is applied. Next, that is your reaction turbine. In reaction turbine, the available energy, that is your kinetic energy and also your pressure, both energy are available in the reaction turbine. So first of all, in your impulse turbine, whatever energy available by the water, that is your pressure energy. But in reaction turbine, kinetic energy and pressure energy, both are the part of the energy provided by the water. So what is happening here? Water enters to the scroll case and moves with the runner through a series of guide gates called wicket gates, and the flow rate and direction can be controlled by these adjustable gates. There are the guide vanes or wicket gates; those are provided to adjust the flow and direction of the water into the turbine. After leaving the runner, the water enters the draft tube as a draft tube which delivers the flow of water exiting from the turbine to the tail vessel. The main types of turbine comes under this category is Francis turbine and Kaplan turbine. This is your one turbine and this is your draft tube. Whatever the water exiting from the turbine through the draft tube to the tail vessel. This is your spiral casing. This is your shaft. Shaft is vertical. These are the guide plates which I am discussing. Guide plates are provided to control the flow of the water and direction of the water inside the turbine. Here better part from pencil water flows. These are your guide plates. Through these guide plates, water is flowed to the buckets or the blades of the turbine. This is another diagram. This is a shaft. These are your guide blades. The volume casing. This is your tail race. This is your draft tube. And this is the rotor. So next come to second part. According to direction of flow through the runner. What is the direction the water is flowing through the runner? According to that, it can be classified as radial flow turbine, axial flow turbine, mixed or diagonal flow, and tangential flow. You can divide turbines into four categories according to direction of flow through the runner. First come to radial flow. In radial flow, the water enters the turbine in the radial direction and comes out also radially. Okay, what is happening in radial flow? Radial flow, water enters the turbine radially and also it comes out in radially. So it may be inward flow turbine or outward flow turbine. Inward means from outside to in, or outward means from inside to outward. For example is your Francis turbine. Next is your axial flow turbine. Axial flow turbine, what is happening here? The water flows parallel to the axis of the turbine. Axis means whatever the shaft axis, that is your axis of the turbine. So water flows parallel to the axis of the turbine. Example is your propeller turbine and Kaplan turbine. Next is your mixed or diagonal flow. In the mixed flow, what is happening? Water enters into the turbine radially at the inlet, but comes out axially. What is happening here? Water enters into the turbine radially, but comes out axially. That is why it is called as mixed flow. So what is happening here? The water changes direction while flowing over the runner vanes from radial to axial. Okay. The example is your Francis turbine, and next is your tangential flow. In your tangential flow, it is also known as peripheral flow type of turbines. That is your Pelton wheel turbine. Next, according to your specific speed of the turbine, can be classified into your, what is, first of all, you should know what is the specific speed of the turbine. It is defined as the speed of a geometrically similar turbine which would produce 1 unit of power while working under a unit head. Okay, what is your specific speed of a turbine? It is a speed of a geometrically similar turbine which will produce 1 unit of power while working under a unit head. Formula is Ms is N root over P h to the power 5 by 4. N is your RPM, h is your head, and T is your pressure. According to specific speed of the turbine, next is a classified into first is your law specific speed turbine. Law specific speed turbine means these are the turbines which were on the relatively high rates and only a small discharge. Example, pattern wheel turbine. In this pattern wheel, what is it mean? The specific speed ranges from 20 rpm to 35 rpm. That means 20 revolution per minute to 35 revolution per minute. And that is for a single jet. And for multiple jet, it can be varied from 35 rpm to 60 rpm. Okay, next is your medium specific speed and high specific speed. So in your medium, it is varies from 60 rpm to 300, and your high specific speed is more than 300 rpm and between 1000 rpm. So in your medium category, Francis turbine is there, and is a propeller and capillary turbine your high specific speed. Next, in your next class, we will discuss about the head of water available. According to the head of water available, what is the classifications of turbine? Thank you.